This is another example of a problem where our function f is the product of two functions. So in this case, the product of 2x plus 9 and x squared minus 12. But again, in this case, it's going to be to our advantage to not apply the product rule and recognize that we can rewrite this function by using the FOIL method basically to expand this out. So we could expand this out as 2x cubed minus 24x plus 9x squared minus 108. So now we don't have the product of two functions. We have a simpler problem to deal with, and we can just evaluate these derivatives, taking the derivatives term by term. So in part A, we want to find the equation of the line tangent to the graph of f of x at x equals 3. So the first thing we need is the derivative of our given function. So using this simplified form of that function, we can take the derivative and come up with 6x squared minus 24 plus 18x. So that's our derivative function. We want the slope of the tangent line, or the equation of the tangent line, at x equals 3. So the first thing we need is the slope of our tangent line. So our slope we can find by evaluating our derivative function at 3, which in this case would give us 84. And to get the x and y coordinate that our point passes through, we can evaluate the original function at 3, which will give us negative 45. So then we can turn to the slope-intercept form, y equals mx plus b. We've already found our slope, which is 84. And we know x and y values that our line passes through. So it passes through x equals 3, y equals negative 45. So we can substitute in negative 45 equals 84 times 3 plus that unknown y-intercept b. So 84 times 3, we can evaluate and then subtract that from both sides to give us b equals negative 297. So we get our equation in slope-intercept form as y equals 84x minus 297. In part B, we want to find the values of x that make our tangent line horizontal. So to know where our tangent line is horizontal, it means the slope or rate of our change of our function, the slope of that tangent line, needs to be equal to 0. So we can take our derivative function, which is 6x squared plus 18x minus 24, set that equal to 0, and solve for x. So depending on how you go about factoring an expression like this, one method is to use the AC method. So we need two numbers that multiply together to give us 6 times negative 24. So two numbers that multiply together to give us negative 144 and add together to give us positive 18. So through trial and error, we could figure out that those are negative 6 and 24. So we could rewrite this as 6x squared, and then we could break this middle term up as negative 6x, so we get the negative 6x plus 24x minus 24, and then factor by grouping. So this will become 6x times x minus 1 plus 24 times x minus 1. So we get 6x plus 24 times x minus 1. And we set that equal to 0 and solve. So in this case, we have to look at solving 6x plus 24 equals 0 and x minus 1 equals 0. So 6x plus 24 equals 0 would give us x equals negative 24 sixths, or negative 4. And x minus 1 equals 0 would give us x equals positive 1. So when x equals positive 1 or x equals negative 4, the tangent line is going to be horizontal. The rate of change of our function is going to be 0.